Hello, everybody, and a very good morning to everybody on Coptrz Con. Thanks for joining us today for the first of the Coptrz Con Summit. And we really have some really great industry-leading guests today. Hello, good afternoon, everybody. Good morning, should I say. And basically, we're here today to discuss the role drones are playing in the drone industry, and also what effect and what kind of future outlook there is for utilising drones. You'll be really pleased to know that we have a really great mixture of guests today. So we have a manufacturer, so we have James from Phase One. We have a survey business owner. We're thanks Simon for joining us today. And then we also have Chris, who's a senior surveyor for Buckingham's Group. The great thing about all this and what we all have in common here is that we're all very experienced in the survey industry. We actually have industry experience, whereas me and James sold our souls to the devil and joined a sales role outside the industry. We're still very much involved in that, and that's where we can offer that really great support, advice, and knowledge along the way to potential customers along the way. So, firstly, I'm going to introduce you to James Wardlow. He is the sorry, Joe, I don't know the correct title, but I know you worked for Phase One as a sales rep. Just tell us a bit about yourself, James, and how you've ended up here.
Yeah, of course. So good morning, everyone. My name's James Wardlow. I'm a area sales manager for Phase One. Phase One is a manufacturer of medium format imaging cameras for various different industrial applications. Primarily, the reputation of Phase One is built from successful aerial imaging cameras. So Phase One started back in 2012 with the industrial business, initially supporting cameras with for optic and Regal scanners, LiDAR scanners, and then more recently developed a range of cameras suitable for UAV. As well as larger integrated solutions. So my background come from an industry or a history of aerial survey operation from manned aircraft surveying using large format camera systems, LiDAR camera systems, hyperspectral, geophysical. So really my background is in the actual operational side of aerial survey. So bringing that experience now into the sales aspect. So really having a good background and knowledge to be able to present our products in Phase One to the customer and really explain those unique benefits of using medium format for that application.
Brilliant, thanks, James. And Chris, you may recognise Chris from a webinar series and case study we did at the start of March now with the new ZEMUS P1 and Wingtron Phantom 4 RTK. Chris, just give a little bit of information about your role and what you've been doing at Buckingham's and where you've come from.
Okay, my name's Chris. I'm based in the east of England. I've been working for Buckingham's for 6 years. Before that, I worked for a company called Team Construction and another company called Sustain. Primarily through all of those, I've been doing bulk earth work, working out large scale volumes for different projects, doing huge surveys, also doing monitoring as well, a bit in the rail. So although it comes from Buckingham's as a whole, we do stadiums, bulk earthworks, rail. It's quite a dynamic company, but primarily myself, I look after a lot of the bulk earthworks projects. And the reason we're going to drones is probably a lot of other people have as well, is because of the mass data capture. We're able to capture a lot of data very quickly, and it also saves a lot of men on the ground, not being around 30 and 40 ton dumpers. I never enjoyed. So you're on pause there, James.
Sorry, mate. We'll come on to why you guys are using drones in your particular industry later on. And also myself, who I probably spoke to a lot of you guys out there, work for Coptrz as a business development manager, working for and helping and assisting businesses in the survey industry to enable them to use drones successfully within that particular vertical. And also Simon, by no means least. Simon, how do you find ourselves here?
Good morning, everybody. Yeah, I'm Simon Judd, and primarily I've been a surveyor for the last 30 years, working across many arenas, be it the civil engineering type of arena through to the built environment, usually adopting the latest measuring techniques that go hand in hand with survey. So, you know, the latest in the GPS technologies that came through many years ago, to the total stations, terrestrial laser scanning. So I've used, Leica instruments, Faro instruments, and it became quite relevant that as the industry is changing fast paced, drones are going to form a very large factor of gathering data for survey industries to not only inform asset owners, but to help us as surveyors with data collection and how to process that through to the deliverables that our clients are asking for. So during the recent pandemics and troubles, I realised that this was a good opportunity to migrate away from working for somebody else and starting a drone business that will push forward and complement my other work in terms of survey, scanning, etc. And yeah, so trained with Coptrz and liaise with James to push me through that sort of journey.
Yeah, that's a really good point. So just for anybody who's watching at the moment or listening, it's a really great opportunity to fire any questions you have to manufacture, people using drones in the field like that. So it's a really great opportunity to put your questions down on the panel at the side and really get some really great in-depth knowledge from people on the panel. So really ask us anything, no holds barred. And we'll be more than happy to help. So I'm going to start with you, Simon. As you've kind of touched on with your introduction, you've worked previously for a survey company and decided to start on your own. Why was drones something which was on the top of your list of priorities when starting up on yourselves?
Well, it comes out of the buzzword of drones in the industry as a general. So, you know, it's something that I've been looking at for, you know, a number of years, and it's for my last company that I was working with. It's a service that we tended to buy in with the administration that goes with not only completing your training, but maintaining your operations manual and the safety aspects of all of that. And it's about clients. Clients are now, every question comes through, can we use a drone? They're not necessarily understanding what the drone can give them, but it's the buzzword in the industry. So they're looking to say, well, how can we adopt this sort of technology and this practices and measuring techniques within the survey? Because on one hand, it could potentially be a cheaper exercise, large data gathering exercise, instead of getting boots on the ground for 2-3 square kilometers of river floodplains, for example. You can utilize drone technology to do that in a faster, quicker manner and in a safer manner. So that was the reason why it's something that I'd kept my eye on, and as I say, the pandemic sort of was a natural progression point for me to say, well, this is a good opportunity to go and investigate drones, get trained to do drones, and concentrate on pushing myself forwards technically on that ability to use those tools to collect data, whilst maintaining the remainder of my experience. I still go out laser scanning, etc. One of the things I'm trying to do is combine those data sets. So how can we use single point measurements in the field? How can we use data collection like laser scanning and combine that with drone technology and the data that's providing to create one homogeneous set for pushing through for clients?
And in terms of, say, how you've seen the industry move over, say, this duration of, I'll say, let's say, call it drone surveys, do you find you're getting more and more people ask for it, or is it certainly a case of you'll get a scope of work come in, you'll look at it, look at the specification and go, well, actually, I'll use the drone on that because I know it's the best tool for the job?
Yeah, it's probably more than one facet to that. One is you get asked for a drone survey. So I think the first thing to say here is, as a working surveyor using drones in my day-to-day business, you quite often get a question where they say, can you do a drone survey for us? Well, the first question you ask, or should be asking, is what is it you're after? Because the drone may be the perfect tool for it, but equally on the flip side, it could be the worst tool for it. So that's the thing. And so it's an engagement process with your client. So it comes 3 ways. One, the client will ask for a drone survey. we'll say yes, that's perfect for it, and we'll guide you through that that process of what you're going to get and what you can use at the other end of that. And the other one is perhaps to say, well, you can use it for this part, but you need to combine it with other traditional methods of survey. Definitely more and more people are asking for drone surveys, or are exploring the idea of using drones in their workflow. So that could be a construction-based firm, for example, who want to monitor how the construction phases are going, from anything from demolition through to reconstruct, stockpile type things. They will have that, and once they are engaged with that, they tend to come back and say, right, now I know what we can use drone technology for. It starts to open up avenues where they can see benefits that they perhaps hadn't thought of before. So engaging with clients and leading them down the journey that we're all going on is quite important on that benefit for me.
And you say typically now, let's say in an average working month, how often you're using drones? Is it on a regular basis now, or does it vary depending on various other factors and parameters?
No, it's regular. I'm flying at least 2 or 3 times a week now. And that could be anything. It could be anything from using it to gather roof data for example, I may be scanning or measuring topographic detail at ground base, but the access to a roof is not available. So, perfect opportunity to add the drone, gathering the data for that roof, and then complementing the information we're getting with other methods. Other times it's pure video. They might just say, we just need a video of the roof, or rather than, I've not done too much pure inspection work as such, but it's mainly having those deliverables that a client says, well, it'd be great if we could see what the roof looks like. Simple video information, videos of flood risk assessment. So I've flown 11 kilometers of a river, just literally videoing the banks and stripping images out, because all they wanted was a condition report, and it was a perfect tool to just let the drone follow the bank upstream and downstream, and provide images of that for a condition. At the same time, we flew it and gathered point cloud data. So they're the sort of things that are coming in every day, finding a new tool, a new use for the tools that are out there.
That's brilliant. Thanks for that, Simon. And over to you, James. Obviously, Phase One, a well respected manufacturer in the airborne industry, making some of the best cameras available. Some people listening now won't necessarily maybe have heard of Phase One in this drone space. What can you tell them about Phase One? Why are Phase One so highly regarded in the camera industry?
Yeah, thanks, Jim. So basically, with Phase One, we have developed a camera that is specifically created for this airborne application. So even down to the choice of the materials used to build the camera, the quality of the lenses, everything that is built for the Phase One industrial cameras is developed purely for this airborne data collection. When looking at the sort of traditional manned aviation sort of aspect, sort of agreeing with Simon, really it was a good method of collecting a lot of data very quickly. So general resolutions are 5 centimeters plus, or for a rural application it'd even be 15 centimeter GSD plus. So you're using the aircraft to really collect large volumes of data very, very quickly to provide to the client. So providing topographical survey, DSM, DTM generation. With the advent of UAVs, it really allows you to focus more attention to higher detail. So you can take, as Simon says, you can take the UAV, you can use it to monitor stockpiles, watch construction sites, really to monitor progress on something, and you can do it on a much more flexible way than what you can really with using an aircraft. You can deploy it very quickly, very easily. They're not expensive in terms of the operation when you compare it to manned aircraft, which is generally several £100 plus per flying hour. So really, yeah, using the correct tool for the correct job is important, and that's what Phase One is bringing to the market. It's bringing a specific camera designed, developed, built for this airborne mapping application, and that's what we're providing the customers with integrations to the sort of most valuable platforms, the Ace Cores, the Aerialtronics, now with the DJI M300. So it's really opening the tools for the customers to be able to use the medium format camera to really increase their data collection and the accuracy of their data collection.
And what is phase one solution if anybody wanted to take a closer look at that?
Yeah, so for the M300, we've just announced to release the P3 integration. So the P3 integration fully integrates with the M300 UAV. It's a custom-built gimbal in partnership with Gremsy, and that basically allows the full control and communication of our payload through the M300, and you're also collecting the RTK data. So everything is completely integrated and full workflow, the same as you would if you had a DJI camera attached to that. But the benefit is you've got a fully metric camera, which is bringing you improvements to your accuracy in the data collection, and then you've got a much bigger frame size for more efficient data capture.
So why metric? Why is metric important, Jimmy? Obviously, people buy things like Phantom 4 RTKs and M300s with the new P1 on, or even Sony AR7s and mount them onto M600s. What's the main criteria difference between, say, a phase one IXM metric camera and some of them other, I suppose you could class them as semi-metric cameras to a certain degree?
Yeah, so the main reason that you would go for a metric camera is it gives you repeatability in the accuracy. Of course, with many commercial cameras, let's use the Sony Alpha as an example, the method of construction of that camera doesn't lead to a very rigid relationship between the sensor and the lens. So what you will find is that over a course of a single flight, you will be able to process it through the software like Pix4D or Agisoft, which is running a self-calibration on the data, and you will be able to generate good results on a one-time basis. When you have a fully metric camera, that relationship between the sensor and the lens is fully known. So it's fully mapped, fully calibrated. It doesn't change because of the materials, the way that the lens is connected to the digital back. That is completely and utterly rigid. So you're taking, again, one step out of the processing because you no longer have to run that self-calibration on the data. What you'll also find is because that self-calibration is not being relied on, because the camera parameters are fully known, you will have repeatability time and time again between data sets. And this becomes important if you're flying, let's say, multiple missions on a single project, and then you have to start amalgamating all of that data together. What you will generally find, especially in the altimetric value, you'll find a lot of fluctuations when using a commercial camera. When using a phase one, you'll have absolutely no issues with that whatsoever because the camera is fully calibrated, and that's really the biggest advantage there is the data accuracy is repeatable, and you know that with confidence the data that you're delivering to the customer is 100% accurate.
And I suppose it's something we don't hear a lot in the survey industry. Like you say, you mentioned about that relationship between lens and sensor and what the materials are made of and what that really influences and brings through into actual the quality of the data from behind. I think obviously probably one of the real things, software's got so good, we can produce good data sets, but that doesn't mean that just because software's good now, we don't have to neglect the quality of that sensor from a survey region. Chris, moving on to you. We've obviously spent a lot of time together over the past few years with Buckingham's and your guys' use of drones. Do you just give us a little bit of history on why you started using drones, sort of the what it was like at the beginning to where we are now? Then we can touch a little bit on about the case study we did.
Yeah, so the reason why we started using drones was before I started. Actually, it was about 6 years ago. The team was a lot smaller. I think the team now is about 24 people. But prior to that, it was about a team of 4 people. And trying to cover the amount of projects in one go for the amount of data that need to be captured just started to become unrealistic. So to try and capture the amount of data that was needed in order to do all the volumes, we decided to go down the route of getting a drone. One of the issues that we found along the way is the quality of the sensor that we had. The sensor we had was a 16 megapixel Fujifilm, and we're flying that at 100 meters on a fixed wing. The issue we had with that was the GSD was about 3 centimeters. So we're getting a lot of areas that were about 100 mil in level difference, which on a large earthworks project, it just isn't good enough. And it also goes back to what James Wardlow was saying a minute ago, was that the repeatability as well that we were getting with that, it just wasn't good enough, and it wasn't trustworthy enough. And so we're about to keep going back to using a walk survey. And so what we've learned is that you need to understand what sensor it is you need for your project. What accuracy are you wanting? Are you just wanting an ortho photo? Because if you just wanting an ortho photo, then just using a 16 megapixel camera and flying 150 meters, or no, you can't fly 150, 120 meters, will be fine. You can get a nice ortho from that, but you can't realistically get good quality, reliable ground data. And so that's where our test came in, James, at Doncaster, where we tested the M300 with the P1, the Wingtra with the XR1 and the DJI. All of those, I think it was, I haven't got the details up in front of me, but it was a reasonably large site. We put 11 GCPs out.
Something like that. 65 acres in terms of size?
Yeah. It's quite a reasonably large site. I went a bit overboard on GCPs. I used 11 GCPs across the project. But I mean, I've got some of the results up here. I mean, the DJI, although it took the longest to fly, it was the cheapest of the three by the Phantom 4, by the way, the cheapest of the lot. 99% of the data came within plus or minus 50 mil. And by that, what I mean is that it came within plus or minus 50 mil of independently surveyed positions, not the GCP. So the process that we use, which I believe should be used for processing drone projects in order to achieve a good quality data set to do earthworks from, is to use all the GCPs and then manually survey a decent amount of separate just spot heights on nice flat areas, which you can then use as a strong comparison against your point cloud that you're going to potentially send to the client, or use in our case for volumes. And that way you can trust the volumes that you've got. So this was about 150 checkpoints, and 99% of them were within plus or minus 50 mil. I mean, that one was flown 54 meters. We had a GSD of about 1.5 centimeters. I mean, we had on the M300, that was flown at 120 meters, but because of it's a 42 megapixel camera, isn't it, James, on the P1?
Yeah, the P1's a 45 megapixel camera.
45, sorry. We had a 1.3 centimeter GSD, and that was flown at 120 meters. And it then also brings into the next point that you can have the Phantom 4, but that should be really good for small to medium sized projects. But if you're going on to large scale, bigger projects, then it may not be. It may do the job, but it might not be the best product for the job, which is where you start looking at either the Wingtra or the M300, because you can fly at a higher altitude with a better sensor. So
I think that's the interesting thing we took from that case study, really, is that a sense of, I think we now know that drones and sensors and photogrammetry, you can collect very high quality survey data from them. I think what you really get is when you invest in, say, better sensors or more accurate sensors, the sense of you're gaining that efficiency on site. So like you've pointed out, Chris, flying at a much higher altitude, generating a much bigger footprint without neglecting any kind of survey grade accuracy. that whole has influence in terms of the efficiency, and certainly working in these environments where time is money. If you can reduce that time on site by 2, 3, or 4 times, then that's certainly going to be happy for the client. It's going to improve processing time with less images being captured. I think that's the thing I certainly took from that webinar, was that they was all in a similar ballpark in terms of accuracy, but in terms of the efficiency side, obviously, like you pointed out, Wing Chun is obviously the fastest. It's a fixed wing. It can do that all day long. The M300 was obviously somewhere in the middle, but has that versatility play with it in terms of using it for multiple disciplines and verticals. And then we just had the little plucky Phantom 4 RTK entry level, but still get some really great high quality results from it. I think we discussed it afterwards, Chris, but I think it's one of those things where we spoke about at the end. How would you choose a drone if you're looking at, say, yourself at Buckingham's now? What would be the ideal tool or the ideal platform and sensor for you to use there now?
It would have to depend on what project that we'll want to go on. It's a bit like what Simon was saying, is that you want to go and use a drone, then a drone might be the best product or the worst product for the job. And so let's say we want to use a drone. Okay, but which drone? What's the size of the area that you want to fly? For example, you could have a project that's 20 kilometers long. Really, is a drone even feasible for that, or do you really want to start looking at a manned aircraft for that? You could use a drone for it, but is it really practical? And it's looking at the right equipment to be practical, basically. And for that reason, I think the most versatile one out of the 3 that we chose was the M300. Although they all provided brilliant results, I found that the M300, a lot of our projects are fair size, and so to cover big size projects and small size projects, to cover everything in one go with one drone, I thought that the M300 would be good. That said, we do also own 2 Phantom 4s, which one's going to be used for picking up stockpiles, and the other one's used on a project on a regular basis for picking up progress on site, for more of a visual aid, really. But they're starting to find it useful on site. There's another one as well that we use as well, is Jungle Stratus. I'm sure a lot of people on here at the moment have already heard of that. But for those that haven't, it's something that is run by a company called Propeller. And basically what you do with that is you can either bring your own data, whereas you load in 2 file types up to the cloud, and it'll bring up the point cloud for the client to use. You can display designs, you can do volumes of stockpiles, you can do volumes to a previous flight, you can do a timeline between different flights. It enables sites to really see their progress on site on large earthworks projects when you're in the middle of it, to really grasp how far along you are in the project and to make sure that you haven't missed anywhere. It's really hard to do that when you're at ground level. When you're up above and you're looking down, you can see everything. And to go back in time 2 years ago and see exactly what was surveyed on that day is almost priceless, because once the work's completed and you've gone over that, you can't capture it anymore. It's done, and it's he said, she said. But when you've got a picture, it's brilliant, and it's helped so much already on certain projects where we've used it quite a lot. And so
I think that's an interesting thing in terms of drone data sets and collection. I think one of the most powerful things is it's all very well collecting all this data and using it, let's say, in a survey perspective. So that might be collecting that data, processing and creating drawings from it. But there's that extra added value of, well, actually, we've captured this data. How do we then get it into the client's hands? And sometimes that's one of the difficult bits with the data sets being so heavy. How can we get that into a client's hands, and how can we get them to get the real value of it? Because as you've touched on, Chris, the data you capture from drones is so visually pleasing just from a looking point of view, but also it's so powerful, so you can use it further down the way with things like site progress reports. Well, how is that site developing over time? So I think our roles as surveyors, they're almost changing so much. I mean, I had a good conversation. One survey company has just said to me, basically saying, well, our job as surveyors, we'll sit in a field all day counting cows, because that's our job, to collect data, analyze it, and interrogate it. I think our role as surveyors has changed as well. Like, who would have thought 10, 15 years ago that you'd be shooting things like site progress photos on site via a drone? I'll tag you in here, Simon. I just wonder if there's any kind of industry observations or anything you'd like to add to kind of the things we've just discussed over the past sort of 10, 15 minutes.
Yeah, well, very much to agree with what the other guys have been saying, but if you're going to get into using drones, there's a question on here about what are the barriers, for example. If people look at it as saying, what do our clients need? Well, you're your own client as well. So think of things about, if you want to get into a drone, then an entry-level type of drone, something like the P4R, the Phantom 4 RTK, can save you time, which saves you money to deliver your client something else. So just because they don't necessarily want to or can understand the drone side of things, take an example. I've recently done a topographic survey of an urban environment where all of the road markings were required. To get all the road markings can take quite a while, but a quick flight with a small entry-level drone and a great orthometric or orthographic photo, you can digitize those lines from your normal conventional stuff. Also, you'll have some point cloud data that will help you digitize levels across those vast areas. So there's a way of utilizing this technology for yourself. And then from that, you can start engaging your clients and telling them how they can use it. Because one of the big stumbling blocks is these data sets are vast. Point cloud data is vast, orthometric, orthographic photos, large TIFF files, or get them down to an ECW type format. But the clients that you have tend not to necessarily have all of the IT infrastructure to utilize that to its best ability. So if you're going to engage your clients with drones and unmanned aircraft, think about what it is, as Chris said and James said, think about what it is you're trying to do, and select a platform that's going to, for your day-to-day work, as Chris has alluded, large-scale, civil engineering projects which are of vast areas, are a different beast to a small construction site of just 100 meters by 100 meters. So your daily workflow should be engaging you and directing you. If you're going to get into unmanned aircraft as part of your workflow, what are you going to do on a day-to-day basis should be directing you as to which type of platform you should be looking at this particular moment. Avenues will open as it goes along, and you may find that your projects grow, in which case you can start investigating a different platform, a different payload, whatever that is. But I would suggest that just because somebody asks you for a thermal survey, you don't go and buy a platform that will be a thermal platform. There's higher opportunities. So if you have a specific need for a specific drone and a specific payload, investigate hiring that. The biggest thing is to understand your industry and understand the tools that are out there to help you get the best for the works that you're doing. If people have got a built environment and all they're looking for is high quality mesh models, you've got to start thinking about where you can fly a drone at low level to get the information that they're expecting. So when you deliver this, ice cream mesh, because you haven't been able to fly low enough due to the urban environment, for example, then your client gets let down and you get let down, and everybody suddenly gets in that process where they say, oh, I've used drones before and it wasn't very good. So I understand your industry.
And I think that's the really good thing you pointed out there, Simon. There's almost two strands to a business, isn't there, using drones? There's drones as a service and drones as a tool.
Yeah.
And they are interchangeable. And I think you've touched on one of the most important things where people are looking at using drones is that management of client expectations. We're professionals in this field, and we need to navigate them through that. Because like you said, anybody can ask for a drone survey without fully understanding the implications or the regulations or anything like that, and you can almost find that normally comes up to the at the final stages when you're trying to get paid for it, when people start bringing up things about, well, I didn't like the quality of that, or why did you miss some areas that, well, I can't fly there, that kind of thing. That all needs to be brought to the forefront of a scope of work of saying, you know, we can do that. Yes, we can do that. No, we can't do that bit. And I think that's the bit where on sort of some of the things I've looked at and spoke to people about, that's always done at the end, where that needs to be brought right forward in the negotiation stage of a client. It's all very exciting when you win work. I appreciate that. And it's all very easy to jump to a client and go, yeah, we'll do that. We'll do this. We'll do this. But that can have such big ramifications further down the way.
Yeah, absolutely. And I think one of the big, it's not necessarily a problem. One of the big issues that I see within the survey industry and using unmanned aircraft is it's very easy to go and buy a platform and then offer a survey service. And that's very different than being a surveyor, and adopting a platform to do your job as the tool environment. It's not just about flying a platform in the air and collecting some photographs and stitching them together. As Chris said, ground control, fundamental, redundancy, fundamental, checkpoints, fundamental, quality assurance, fundamental, transformations from a WGS84 to OSGM15 to local grid, all fundamental. And the drone platform is not going to do that. You as a surveyor are going to do that. It's just another tool in your box to help you navigate your way through the survey industry and provide your clients with everything that they're expecting from there. So if you're not a surveyor and you're expecting drones to give you good quality survey data, you'll be lucky when it comes out right. When it goes wrong, you won't know it's gone wrong and you won't be able to fix it. So, you know, that's the ballpark. I can go and buy a set of sockets. I'm not a mechanic. So it's the same analogy, you know.
Exactly. I think it's that understanding that it's all very well, you know, collecting some data, putting it through Pix 4D and going, that looks great, but looks can be deceiving, and then that can then obviously you can soon have a client on the back of you saying, that's not right, mate, sort it out, go back and do it again. I think in terms of I say anybody who's looking at who want to start using drones for survey applications, I always break it down into sort of 4 threads. And as I think we've discussed, Simon, it is a steep learning curve at the beginning. You know, it's that I suppose flying a drone, 1, it's the rules and regulations, 2, it's data capture, 3, how to collect good quality data, and 4, that processing side of it. You know, how am I getting the most out of the data of the processing side of it? And I think once you've mastered all them, it is pretty plain sailing once you get over that first initial a steep rise in learning, and it is that thing. That's something we try and help with at Coptrz and tick all them 4 parameters, being able to do it under one roof. James, I'll tag you in there. Don't want you to be falling asleep because you've not spoke for a while. Is there anything you'd like to add in terms of where you've seen the industry progress over the past few years? Obviously, as you said at the start, you come from very much a traditional manned aviation side. Do you see any changes in that with adoption of drone use? Where do you see the industry heading over the next few years?
Yeah, I mean, absolutely. I would say that from where I came from, operating survey equipment in the back of aircraft, it was for what we can really classify as very traditional output. So orthophoto, DTM generation. It's usually used for rural planning, urban planning, floodplain management. Whereas what I've seen now with the advent of UAV is really quite a big shift into innovation with what the tools can be used for. So it's not only being used for a topographical survey. We've started seeing UAVs being used to fully recreate in 3D digital twins in the likes of heritage inspection. So I mean, for me personally, that is an exciting application that I'm starting to see more use cases for. The other side, of course, is precision agriculture. We're seeing cameras being used for very high resolution data collections of agricultural fields, and then through AI machine learning, we're seeing phenotyping and other precision agricultural techniques being used to bring forward higher yields in crops. So I think with the UAV, it's really opening up more and more tools for using high resolution cameras and other high resolution survey equipment for a wider range of applications than what the original traditional manned aviation was actually bringing to the table. So I do see a lot of innovation coming forward, and as the rules and regulations start to better allow for more flexibility, more freedom, larger data collections, then I do see UAVs expanding into much wider, much broader data collection and activities and applications.
Well, I've got a question for you, James. It's from Martin on the panel. He says, "What's the panel's opinion on the role for LiDAR sensors in drone surveying? Current adoption, future potential, and technical performance." I know. I've had good LiDAR conversations with with everybody on here over the past, and I'll come to each of you individually. But I will start with you, James. I know you've used LiDAR before from manned aircraft and had that feel for it from a UAV. What's your thoughts on that side of things?
No, I mean, certainly in terms of again, it's a tool. It has certain advantages in its ability and its use. The main advantage is, of course, that you're getting a certain amount of vegetation penetration, so you're getting bare earth measurements, whereas with the photogrammetry, you still have to account for this. You can do other applications. It's a pretty useful tool for monitoring power line sag, that kind of thing. But in terms of accuracy against photogrammetry, if you were to use a LiDAR scanner against a camera, against a solid object, you can still generate much higher accuracy from photogrammetry than with LiDAR. So when going forward with LiDAR, I would say, in my opinion, that you really need to assess it. Is it a tool that I really need to use, or can I achieve this output using a camera? Of course, if it's to monitor vegetation growth over the top of a power line, for example, then yeah, the LiDAR is a tool for the job. If you're going to recreate a building in 3D, then I would go for the photogrammetry.
I think that's the interest. I think there's quite a few misconceptions about LiDAR, which I certainly hear in my role. Things about it's more accurate. I think the data also from LiDAR is something which people can be quite shocked with. Certainly when you see it from a drone data set, it can be so noisy. I think the Regal and Optec, they're in different territories with LiDAR sensors, but some of the more entry-level LiDAR systems, the data can be so noisy, and you can have point spreads of 100 mil still on a £50,000 system. Like you've said, yes, there is certainly applications for it, but it's not the be-all or end-all. There is certainly a lot of post-processing involved after data capture and processing it to get it down to them kind of levels where you can start using it for survey interrogation of the data. Simon, have you got any experience at all with LiDAR, obviously from your terrestrial scanning side of it, anything from the airborne side, or seen any data or from it?
Again, as James said, I have seen airborne LiDAR data, creating DEMs, etc. I've not had experience myself. You know, the terrestrial laser scanning is a slightly different, same avenue, but slightly on one side. The accuracies on there are sort of better. So yeah, it's one of those things that we were talking about earlier. If the need for bare earth measurements through vegetated areas is what's required, well, it's a very quick way of gathering that type of information, but you've got to understand the deliverable. It comes, as with all of these things, it comes with an accuracy, and as surveyors we understand that, 1 to 50, 1 to 100, 1 to 200, etc., etc. So if to gather information to inform you as a design team of a vegetated area, then LiDAR may be a solution that you want to do. You could complement that with some form of ground-based measuring to give you some confidence in the results that you're seeing. And if an area is specifically of high interest, then you may do a localized survey of that area. But we've seen it many times, that flying jungle type environments to find historical features and structures. It's a fantastic tool for it. And I guess as technology advances, so will those tools advance with it. But you're not gonna fight your way through a very dense vegetated area to find things that you may or may not see. But LiDAR will give you a much better tool to analyze that site and make further decisions to go forward.
Anything from you, Chris?
We haven't really used LiDAR from our company, to be honest. We just use the photogrammetry side of it. We have had one project where LiDAR was supplied by us, and the levels were up to 0.5 meter out of level, because they basically picked up the top of the vegetation and they haven't got through to the ground level. For that reason, although LiDAR, people keep punching around the wires, it can go through vegetation. It can't. It needs to see ground. And for that reason, I think that people using the LiDAR need to be very experienced and understand what they're looking at in order to produce an accurate survey at the end of it. Otherwise, I think LiDAR in the wrong hands, similar to photogrammetry, can be extremely dangerous because, right or wrong, you're still going to get a product at the end of it anyway.
I think with LiDAR, like you said, that interpretation of it as well. Yes, let's say we get through part of a vegetated area. Well, are them returns really from the ground level, or are they just on a thick covering of leaves or something like that? It's not the be all or end all, and certainly we can't hang our hat on that data and say yes, I can 100% guarantee that this is the bare Earth model. It's always open to a bit of interpretation, and I suppose how much confidence we've got in that data we're handing over. Is that really the true bare Earth? So I think that's a really good broad opinion from all the panelists on LiDAR. I've got Martin a bit more directed at you, Simon. You did mention about the road survey, about picking up lines. Martin asked, how was the safety aspect during the road line surveys addressed? Road closed, marshalling, OSC or PFCO stand permission? Is this a practical aspect of performing an urban survey that is significant barriers for drone surveys? How do you fly safely in that environment?
Yeah, well, more than a road, it was more of a urban area with roads and car parking. So that's the first thing. But yeah, in terms of safety, it's you've got your guidelines that you're allowed to fly under, whether it's your PFCO, your GVC, your operational safety case, etc., etc. The most critical part of any flight is the point which it leaves the ground, and it's the closest you're to people, unless you have some form of safety case that reduces those separations. The biggest factor in terms of safety is know your system. Make sure your system is well maintained. Make sure that you understand it fully. You know when a potential problem is arising. Use it. Every site is different. So in terms of flying with it within a separation for a PFCO, for example, the 50-meter separation bubble, you have the takeoff and landing, and that was mitigated by having a safe takeoff and landing zone where people weren't allowed to come. We had spotters out in amongst the car parking area so that we could liaise with each other and inform anybody of any potential problems that may or may not arise during the flight process. The flight was conducted at 70+ meters and was outside of the separation distances that we're flying to. And you plan your mission to, for example, on a road, you wouldn't plan a mission to fly linearly along a road, because if there's anything that's going to happen, it's going to come along and likely to come straight down on the road. But if you have to fly a road and there isn't a road closure, well, think about how to man and safety plan that flight. Go across the flight path. You may be doing more turning circles and collecting more images, etc., etc. But you're always thinking fundamentally of putting the safety in place and then doing the job, not finding the quickest and easiest solution to do the job at the risk of safety. So, of course, if you could close the roads, that's the first option you'd have. If you can get rid of everybody, that's the option you take. But when these things in an urban environment aren't available, then you have to start putting additional safety measures. That could be anything from spotters to to flying high enough so that you can take control of the aircraft, or move it out of the position of those areas that may or may not be deemed to be or safety critical. So yeah, every job's different, and it's all about the planning. It's all about what you're doing, how you're doing it, understanding your system, making sure that you're rotating batteries, make sure they're stored correctly, charged correctly, make sure that you maintain your aircraft, make sure you check and follow those safety procedures. One of the things you'll do in your training, if you follow the route of unmanned aircraft, is you will have checklists. It becomes very easy to just think, oh, I know how to put the drone together, I know how to take the drone off. But if you don't follow these strict, regime of your work, then you won't ever be flying safe. That's why manned aircraft have checklists. There's a pre-flight checklist, a takeoff checklist, a landing checklist. If you get that into your working profile, then you will be flying safely, provided you fly within your guidelines, your permissions that the CAA have provided you with. Then you will be flying safely.
And I think that's the interesting thing from it, is there's no nothing if you're in your PFCO or operation authorization. There's nothing in there to say that you cannot fly over the M1, for instance.
Yeah.
Should you? Is it safe to do so? Well, that onus falls on you to, as you've said, mitigate as much risk as possible, get that down in your risk assessment, because your risk assessment is essentially your argument on how you're going to conduct that safely. And as you've pointed out, if you can do that within the realms of what's printed on your PFCO certificate, then you are free to fly. But should something happen, they're going to come down on you or going to ask you some questions of how did you mitigate that risk. If you can satisfy all that needs, then you're free to fly. I got a question from Jonathan. This is probably a bit more directed at Simon and you, Chris. How do you compare GPCs with drone data if the GCPs equal bare earth and drone data is the grass cover? So I think John was just hinting at, like, if you're on an area where not necessarily heavily vegetated, but there might be some freshly cut grass, or maybe some grass which hasn't been cut in a few weeks. Is there anything we can do for that? Is there any software algorithms like lowest point or anything like that? How would yourselves deal with something like that in practice?
You want Simon, or do you want me to
you go first, Chris, if you like. Yep.
What I would do, if there's any areas which are grassed, I'd make sure I'd get some physically measured points in there. Because what you're going to have to do more than likely is that the level is probably going to be at the top of the grass. There's no way that photogrammetry is going to be at ground level. It can't be. Hence the question. So I'd process it all, knowing full well the level in that area is going to be. I'd then look at doing an isopath between the survey level and my point cloud, knowing the difference. And what you should find, if it's a nice nominal thickness, is that, let's say the grass was 100 mil thick, you should find in all of that area, on all of your checkpoints that you physically surveyed, that it's 100 mil. I'd then drop the survey in that area by 100 mil. But I would only do that if that was a section of a survey. If the full site is all grass cover, should you really be using, what Simon was saying at the start of the talk, should you really be using the drone for that? If the whole thing is grass cover, then you probably shouldn't really be using the drone. Then you might want to look at LiDAR, but then how dense is the vegetation? If it's really dense, you might either want to look at doing a physically walk survey to get some land to physically walk it, or get some veg clearance in there, get it that way. It'll have to be done on a case-by-case basis. But generally, you want, with photogrammetry, you want to really, where possible, survey bare earth. You don't really want to be surveying or going over a lot of vegetation, because you're going to encounter errors.
Yeah. And anything you want to add, Simon, to that? How would you negate or mitigate that?
Yeah, I would totally agree. I mean, but again, it's potentially down to the use of the data. If you're, let's say, for example, 1,000 hectares that's required for a general ground level type study where a ½ meter contour is good enough, then potentially you can think. But it's about engaging your clients, telling them, as Chris said, this is not bare earth. So we could be in error by 100 mil, 300 mil, whatever that length of grass is. But if the nearest ½ meter is all you're looking for, because you're trying to say, can we, how much topsoil are we likely to be taking off of this area? Well, a ½ meter contour may be good enough for that each way. So that's phase one. Let's get some large scale data, and then we can start analysing and starting a design process. But if somebody said, I want the absolute finite level to a 1:100 survey from grassed areas or fields, then as we said already, that potentially a UAV is not the way forward. It can be used to combine and complement the data. But one tool, the same as every survey, one tool is not necessarily the answer. It's about what is the project, what are we trying to do, and which tools can we use to do that. You've got to remember that some hard standing surfaces are extremely difficult to reconstruct. Homogeneous empty green or dark shadowy tarmac can create very noisy data, regardless of the tools you're using. So, it's about understanding how the processing is going to go, what you're trying to do, and how you're going to collect that data. And as we've already said at some stage, if it's just about an ortho photo, well, you know, that's a fantastic tool to use a UAV. You can get large scale areas, a great informative tool, you know, to start a process, whatever that process may or may not be. You know, dense areas of trees, water, all of these things, you know, are very difficult to get accurate information on. You know, almost impossible for water. You know, you might just about get water level close to the bank, but the moment you come into the water, it's, you know, it's horrendous. So it's understanding.
I did see someone do it. They put some. They had to pick a very calm day, but it was only very shallow riverbed, and they managed to put some GCPs underneath the surface, and created a river survey of some sort by putting these GCPs underneath the water. I mean, they had to pick a very calm, flat day where there was no ripples or anything like that, but managed to actually create of some sorts a small riverbed survey of sorts. I mean, I'd be interested to see the data from that, but I suppose it comes to the stage of things like that, of that experimentation. And if you could also do a more traditional survey on that, just doing that comparison, well, is this a worthwhile methodology going forward, or can we knock it on the head and say, well, probably not going forward, something like that?
Yeah, absolutely.
So we're just coming to the last of the last 5 minutes now. I suppose open up to the panel. Is there anything you guys want to add? Any industry observations? Anything which you've learned mostly over these last few years? I'll start with you, James.
Yeah, I think really the main thing that I would say is an observation that I've seen coming from the manned aviation and into the unmanned aviation. There seems to be a very big emphasis from the customer on the way that they select their tools and select the platform. What we generally see is that they're quite willing to spend a lot of money on the platform and then look at the actual sensor itself as a sort of a secondary item. And coming from the manned aviation side, it's a bit of a backwards way of thinking about it, because of course the actual main part of the UAV tool is the actual sensor. So the platform at the end of the day, that's just carrying the tool. The main tool on the bottom that's hanging from that and taking the measurements, that's where the money needs to really be invested. And what I would say at the moment, in my observation, is that it's the wrong way around. It's sort of somebody buying or akin to somebody buying a gold-plated tripod and then sticking a ball of string and a plumb line from the bottom of that tripod. So that's really, I would say, my main observation at the moment of the UAV industry and the way that it's operating.
And a quick 30 seconds for you, Chris.
Yeah. So right, over go. No, my only observation really would be, well, I've actually done a check with the rule of thumb across the industry for 3 times GSD. I don't know if you've done any of the similar checks, James or Simon, but I took it from all the information we did from Doncaster, and then I also did it with a separate data set from our drone on a different project. So that's 4 different data sets. Across all of them, it was an average of 86% of the data came within 3 times the GSD. By the data, I mean, again, independently surveyed, physically surveyed points across the project. So that's that to the point cloud. And I think that's quite useful when trying to gauge what sort of accuracy you're wanting to achieve. Is I think that the main thing we need to be looking at is the GSD, the pixel size which we're going to be picking up. And then from there, we can use the rule of thumb 3 to sort of gauge how accurate our data at the end is going to be. And not that rule of thumb that I've checked. I'll feel confident using that moving forward for any surveys that ourselves would be using to achieve a good result. I thought that would be useful for anyone else as well.
That's brilliant. We've actually got a write-up of the case study we did with you guys coming out shortly. So if anybody's still listening, there'll be a long case study documentation which I still have to proofread, but it's a really, really great almost point of contact. So if anyone asked about what is realistically can be achieved with drones, and the accuracies from it. It really goes into a lot of detail about that, a lot of charts and isopacks and stuff like that. Simon, you've got about 10 seconds, mate. Go.
No, it'd be straightforward and simple, really. If you're already thinking about engaging with drones in your daily workflow, you've probably made the biggest decision you're going to make, and that's to start looking at it. You know, it's not a great expense to get in, provided you find that you've identified a workflow for it. You know, it is a steep learning curve, as James said, but it's a journey. Get involved and engage yourself with it. Don't just buy it and put it on the shelf. So.
That's brilliant. That's something as Simon's pointed out, we can provide at Coptrz that full level of support, help along the way. First of all, thanks very much for you guys to join me today. It's really great appreciated when we get manufacturers, customers coming through and helping us with these sort of events. It's really greatly appreciated, and we couldn't do it without you. Also, all the people who've bothered to actually sign up today and join CoptrzzCon and get involved, thanks very much as well. And if you need anything, then please get in contact with myself from the survey side of it. My details should be on the board there. You can email me on that. And yeah, thanks everybody. Have a great day, and I'm sure you'll see at some further events at CoptrzzCon. Thanks everyone. Bye.
Thanks, guys.
Thank you.